In 1987, a small research antenna outside Albuquerque detected a radio signal that wasn't supposed to exist. It didn't match any satellite. It didn't match military frequencies. And it wasn't random noise. Because every night, at exactly 3:17 a.m., the signal appeared for 12 seconds. Then it vanished. For weeks, the scientists simply recorded it. Until one night, someone decided to answer it. The monitoring station itself was nothing special. It sat on a quiet stretch of desert land about 30 miles outside Albuquerque, surrounded by scrub brush and low red hills that seemed to swallow sound after sunset. The university operated the antenna mostly for routine radio astronomy work, scanning the sky for background radiation, logging faint bursts of cosmic noise, and teaching graduate students how to operate sensitive receivers. Most nights, the equipment recorded exactly what you'd expect: static, distant satellite chatter, occasional atmospheric interference. But on October 12, 1987, the receiver picked up something that immediately caught the operator's attention. It wasn't noise, it was structured. A clean, repeating burst of radio energy. At first, the operator assumed it was a passing satellite. Signals like that happened occasionally when older satellites drifted through certain orbital paths and briefly crossed the antenna's line of sight. But satellites move quickly. Their signals fade within seconds as they pass overhead. This one didn't. The transmission remained perfectly steady for nearly 12 seconds before abruptly disappearing. Then the receiver returned to silence. The operator logged the anomaly, saved the recording, and went back to monitoring the equipment. But the following night, at exactly 3:17 a.m., the signal returned. Same frequency, same pattern, same 12-second duration. For the next few nights, the researchers treated the signal like a technical curiosity. They recorded it, archived the waveform, and compared it against databases of known transmissions. Weather satellites, military communications, orbital telemetry. None of it matched. The signal's frequency sat in a quiet portion of the spectrum rarely used by commercial systems. More importantly, the source point didn't drift. When the antenna locked onto it, the coordinates remained fixed against the background stars. Whatever was transmitting it wasn't moving through orbit like a satellite. It was coming from a point that stayed perfectly still in the sky. That detail made the situation stranger. Satellites move. Space debris moves. Even distant aircraft produce signals that shift as they pass overhead. But this signal behaved differently. Each night, just before 3:17 a.m., the receiver would remain silent. Then suddenly, the waveform would appear. 12 seconds of clean, repeating pulses, before disappearing as abruptly as it arrived. The pattern never changed. The timing never shifted. It was so precise that one of the graduate students began joking that they could set their watches by it. After the 7th night, the joke stopped feeling funny. By the 2nd week, curiosity turned into investigation. The team began running calculations to determine the possible origin of the transmission. If the signal was coming from orbit, its source would have to remain directly above the same coordinates every night. But the orbital data didn't support that. No known satellites passed through that position at the exact time the signal appeared. They even checked classified launch records that had recently been declassified. Nothing matched. The only remaining explanation was uncomfortable. The transmission wasn't coming from something orbiting Earth. That's when one of the younger researchers suggested something unusual. Up until that moment, the team had treated the signal like a one-way broadcast, something to record and analyze. But if it truly was a repeating transmission, there was another possibility. What if the signal wasn't just noise or telemetry? What if it was a message designed to repeat until someone responded? The idea sounded ridiculous at first. Research stations didn't answer mysterious radio signals. That wasn't part of the protocol. Still, The more they discussed it, the harder it became to ignore. The station's lead professor initially rejected the idea immediately. Transmitting on that frequency without proper authorization could cause interference with legitimate systems. More importantly, they had no idea who or what might be broadcasting the signal. Responding blindly felt reckless. But curiosity has a way of eroding caution in scientific environments. The signal had appeared every night for nearly 2 weeks. Same time, same pattern. Eventually, someone asked the question nobody had answered yet. If it really was repeating intentionally, what would happen if they acknowledged it? The following evening, they prepared a simple test. Nothing elaborate, just a short transmission sent on the same frequency immediately after the 12-second signal ended. They chose a basic sequence of pulses that could easily be recognized as intentional. When the clock approached 3:17 a.m., the entire team gathered around the receiver console. The signal arrived right on schedule, repeating its familiar waveform. 12 seconds later, it vanished. The room went silent. One of the researchers reached forward and pressed the transmit switch. At first, nothing happened. The transmission went out exactly as planned. The receiver returned to silence. For the rest of the night, the equipment recorded nothing unusual. By morning, most of the team assumed the experiment had been pointless. If the signal had been an automated broadcast from some unknown source, it probably wouldn't respond anyway. Still, they kept monitoring the receiver the following night out of habit. When the clock approached 3:17 a.m. again, the control room filled with quiet anticipation. Right on schedule, the signal returned. The same frequency appeared on the receiver, but something was different immediately. Instead of the usual repeating pattern, the waveform fluctuated in a way the researchers had never seen before. The pulses were still there, but their spacing had changed. The pattern looked altered. At first they assumed the equipment was malfunctioning, but the instruments confirmed the data. The signal itself had changed. They replayed the recording several times, trying to compare it with the original transmissions from earlier nights. That's when the realization spread across the room. The pattern wasn't random. It wasn't noise. The spacing between the pulses matched the same rhythm they had transmitted the night before. The station had sent a signal, and now the unknown source appeared to be echoing it back in a modified form. The signal still lasted 12 seconds. The frequency was the same. The coordinates in the sky hadn't moved at all. But the pattern had changed for the first time since the station detected it, and according to the recordings, it had changed the night after they answered it.